As networks virtualize and become increasingly distributed, demand for data centers continues to grow. The challenge is that this growth comes at a price to the environment. Data center facilities and the servers housed within them require a huge amount of power and therefore have a significant carbon footprint. And at a time where sustainability is at the top of the agenda, it's important for data center providers and the direct consumers to consider how they can minimize the environmental impact that these facilities have. We see that there are three key drivers for data center power consumption that are important to consider. The first is the power source, so it's really important to consider where the power is coming from, whether it's from a renewable or a non-renewable source. And a few players, including Facebook, Microsoft and Google, have committed to going 100% renewable, but this is ultimately only a commitment at this stage and there's still a long way to go before a wholesale transition to use of only renewable energy is made. But one company that has been making good moves in this space is Echelon. They're an established data center provider and they collaborated with Biocore in Ireland to supply their data centers with biogas, which is a sustainable energy source. And then they've also used the heat generated from the facility to dry the byproducts from the energy production to create fertilizer for local farms for their crops. And so that's a nice example of a company not only moving to a more renewable power source, but also being able to make their operations more circular. The second consideration for data centers is cooling. So data centers servers need to be continuously cooled, and there are two primary means of cooling these servers, either air or liquid. And air cooling's been the predominant cooling method in traditional data centers, but actually liquid cooling is more efficient. It's more compact, it's also far more effective at carrying heat away from the source, which means that liquid cooling solutions can reduce power usage effectiveness by over 20% when compared to an air-cooled solution. And the third consideration is server architectures. So when data center servers are too close together and are physically or logically linked in an inefficient way, that drives the need to consume more power. And so particular care needs to be taken when designing that data center layout, both physical and logical, in considering the future mode of operation. And then if the facility expands, providers have to think about how the existing and the new servers will link together. And AWS is a company that's had success with this, and a study conducted by 451 Research showed that AWS's data center infrastructure is 3.6 times more energy efficient than the median US enterprise data center, due to more energy efficient servers, higher server utilization, and also more efficient data center facilities. And one of the ways AWS has achieved this is by removing the central uninterrupted power supply from its data center design and integrating a small battery packs, and also custom power supplies to its racks to reduce energy conversion loss by about 35%.